And so we can do many kind of operations, right? So the signal processing is a group of operations applied to an input signal and resulting in another signal as an output signal. So the mathematical representation or transformation of one signal to the another signal is generally represented as y of n is equal to capital T into x of n. So we can do many operations on signal. So these are all these kinds of signals we can do on the signals: shifting operation, time reversal, time scaling, scalar multiplication, signal multiplication, and signal addition. So the time shifting operation. So the time shifting operation, in the sense, the shifting operation takes the input sequence and shift the values by an integer increment of the independent variable. The shifting may delay or advance the sequence in time. So depending upon the value, here this is our g of n signal. This is the example given here. So here, right from the -1, we are having the amplitude value. So this is represented here in this example. N is equal to -1, 0, 1, 2, 3 till 10. We have our amplitude, and the corresponding amplitudes are represented against this column g of n. So here, this n naught is an integer. So here g of n plus 3 or g of n minus 3. These are all the shifting operation. You can have n in general. We can have g of n minus or plus k, right? So plus or minus k. So if you are doing your operation in the advanced signal, advanced way, or delay, you want to delay your signal, depending upon that, you have to change your signal here, plus or minus. So in this, we are having our signal as g of n, and here we are going to calculate g of n plus 3. So how to calculate this? So we have to shift our signal. Which direction we want to shift? Sometimes we have a confusion either to the positive x direction or to the negative x direction. So here my signal, in the example, that is in g of n, my starting value of my signal at -1, n is equal to -1. Here we are asked to calculate g of n plus 3. So the blind clue to calculate this is, so you have to substitute a number here. In that way, such a way, you will get your answer is equal to 0. That is for your 0th position here, right? So 0 position will be calculated at -3 value. So if I am substituting -3 at this point, then only -3 plus 3 will be equal to 0. So my signal at n is equal to 0 in my g of n will be available here, right? So -3. So -3 position, that is the meaning. So what is the case here? Here my starting value is -1. So I have to add -3 in this case to find out my starting position for g of n plus 3. So -1 -3, so -4. So my starting position of my signal g of n plus 3 is -4. Right? So in the -4 position, I will have my amplitude, whatever I have at the location, -1 in my original sample. That is what given in this table. Look at this table. So here at n is equal to -4. This is my -4 location. At that -4 location here, my amplitude value will be equal to the amplitude whatever I have in my signal g of n at the position n is equal to -1. So in the similar way, we can do n g of n minus 3 also, right? So we will do our shifting in the opposite direction. So in this case, we are doing our shifting in the negative x direction, that is towards -infinity. We are doing our shifting here. If we are having our signal g of n minus something, then we will do our shifting in the positive x direction. So we should remember this case. The shifting is very, very important.